Hello, I'm going to present the Chapter 7 from 115 to 155. So from the previous starting, we may know what is the view, and here is the guidelines for updating a view. At first, we need to know what is a simple view. Simple view is created based on one table with no function, no order by, no distinct, and no group by. And insertion, deletion, and update can be performed on simple views. Here, from the below, we get an example. Here we have a student's table, and we get four tuples on this table. And next, we need to create view top student, and we select student's ID, name, and GPA from the student table, with the GPA greater or equals to 3.8. And next, the view is created, and if we print the view top student, we get the tables here. And next, we're doing the deletion on this simple view. So because this top student is created only based on one table, student, so it is a simple view. And next, we delete from this simple view with the name Tom. So one row is deleted, and we print this top student view again, and we find that Tom is deleted. And if we print the student, we also find that the Tom is also deleted in the students table. We can find Tom here. And next, in contrast, we have the complex view, which is defined using multiple tables or using group by or order by, and so on. And next, we also have an example. To explain this example, we need to add two more tables, enrollments and courses. And this is the enrollments table. We have the student's ID reference from student table and the course ID reference from the course table. And we have another attribute as score. And we create the student course view based on the student table, the enrollment table, and the courses table. And with the student SID, student's ID in the student table equals to student's ID in enrollment, and the course ID in enrollment equals to course ID in course tables. And here view is created. Here, if we print the student course view, we can get this table. And next, complex view are generally not updatable. So next, we will do a deletion in this student course view. We delete the student's ID equals to B001, and the question is that should we delete the table from students or from enrollment or both? So we need to do it. So we need to try it, and from the result, we can see that if we print the student course, we can see that B01 is deleted. And if we print the students table here, we can find that the B01 named Bob is still there. And if we print the enrollment table, we can find that B01 is deleted. So the answer to this question is that we delete the student from enrollment, only from enrollment. And next, one more example. Here we have the age distribution with the attribute age and the total number of students in this age. And we're using the group by. And here is the new students table. We add Jack with the age 19. So here we have the age distribution view, and we have one student at 22, one student at 23, and two students at 19. And which student should be deleted? And from my practice, I found that if we running this statement, we will get an error that data manipulation operation not legal on this view. So my answer to this question is that no students will be deleted. And next is the view materialization. A view may be materialized in advance to improve efficiency. So which means that, so from the previous learning, we get that the view will only be materialized when the query happens. So if we materialize it in advance, it can improve efficiency. But if materialized view are not query, view materialization may waste resources. So we can easily understand that. So there is an interesting trade-off between enhanced performance and overhead. And this technique is widely used in industry. And next is the view maintenance. View maintenance address the issue of propagating the update on base relations to the views that are defined from the base relations. And from below is an example. We have the students table with 3 tuples, and we have the age distribution view, same as before. And here we are doing an insertion. We insert one student with student's ID B005 with the name Jack and age 19 and GPA 3.3 here. And we can print the student table, and we find that Jack is inserted. And we also print the age distribution view, and we find that the total number of students whose age is 19 is increased by 1. So here we get the incremental view mechanism. So we do not rematerialize a view from scratch. Instead, modify only the part of the materialized view that needs to be changed. So the only change is happening here. And next, we have one more example about the incremental view maintenance. And here we need to delete from the enrollment table with whose student's ID is B04. And we print the enrollment table, and we find that B04 is deleted. And we also print the student course, which is based on the enrollment students and courses table, and we find that B04 is also deleted. But if we print student table, we find that B04, which is Mac, is still here. And from the text, we can get that tuple T, which is B004, is deleted from enrollment. And the maintenance notification about deletion about the student ID equals to B04 is sent to the view, which is the student's course. And this will form a maintenance query, which is sent to the student table and the courses table. And students table and courses table evaluates the query and sends the result with the name and the course ID to the student course view. And the student course view is updated. So the B004 is deleted from the student course view. So that's all. Thanks.